Today we're going to learn what a simulation is and how we can use it to help predict probability. A simulation is an experiment that is designed to model the action in a given situation. Simulations often use models to act out an event that would be impractical to perform. Designing a simulation is a more practical way of determining the experimental probability of an event. Objects that are frequently used in simulation experiments include spinners, dice, coins, playing cards, and number assignments. We want to figure out which simulation model would be appropriate to use in each of the following. The first one says Marley's mom is having triplets. She wants to design a simulation to determine the genders of the babies. Well, in this case, it's not like we can go out and ask a bunch of women who are pregnant with triplets to give birth and tell us the genders of their babies. So, this is why it is impractical to actually complete an experiment for this event. And instead, we would use a simulation. Well, in this simulation, we need to look at what we're trying to figure out. We are trying to determine the genders of the baby. Well, we know that when a baby is born, they are assigned a gender of either male or female. So there are two genders that are options. Well, when we think about all of our different simulation models and what we could use, we have spinners, dice, coins, cards, and number assignments. Which of those could be used to have just two outcomes? We know that coins can be used because coins have exactly two outcomes, and that's what we're looking for here. So a coin would be the best model to use for this particular experiment. Number two says a restaurant is giving away one of 5 different toys with its kids' meals. Kevin wants to design a simulation to see which toys he would get if he purchased 10 kids' meals. Well, when we look at this, we know that there are 5 toys. So, since there are 5 toys, and if I look at my different simulation models, I have spinners, dice, coins, cards, and number assignments. Well, dice have 6 outcomes, which is not 5. Coins have 2, cards have 52. So my options here are either using a spinner and splitting it up into 5 sections, or giving number assignments, and 1 through 5 can be a different toy. Either of those would work for this one. It would probably be easy to do a 5 section spinner, but you also could say number assignments for this one. Number 3 says Mr. Chen must wear a dress shirt and tie to work. Each day he picks one of his 6 ties at random. So since he has 6 ties, I want you to look at your different simulation models and see which one of those would be best to use. Put your answer in the chat. For this, since there are 6 outcomes, a 6-sided number cube or dice would be the best option. Number 4 says an ice cream store offers waffle cones or sugar cones. So I want you to figure out which simulation we should use for this and put your answer in the chat. Since there are 2 options, either waffle cone or sugar cone, a coin would be an easy option to use for this. Number 5 says an electronics store has determined that 45% of its customers buy a widescreen television. Well, for this one, it would probably be best to use number assignments. And you can make your number assignments so that 45% of them would represent a widescreen television and the other 55% of them would not. Now go to page 31. Where it says performing a simulation, we are going to actually look at what we could possibly do. Number 1 says a supermarket is issuing one of 6 different in-store discount coupons to each customer who enters the store. If the coupons are given out randomly, design and complete an experiment to simulate which coupons would be given to the first 15 customers. Well, what we're looking at here is the fact that there are 6 different coupons. So if there are 6 coupons, which model could we use? Put your answer in the chat. Because there are 6 different coupons, we know that we should probably use a 6-sided number cube or a die. So we are going to roll a number cube, but that's not the only thing we're going to do. If we read the rest of the problem, it says we want to simulate which coupon would be given to the first 15 customers. Well, if we're rolling a number cube and we want to simulate the first 15 customers, then we would need to roll a number cube 15 times and figure out which one represented each coupon and use that for our experimental probability. Number 2 says every marathon runner that passes the halfway point gets a gel pack. There are 2 different flavors available and they are given out randomly. Design and complete an experiment to simulate which gel packs will be given to the first 12 runners to make it to the halfway mark. Well, for this, we know that there are 2 flavors that are available. So, which simulation model should I use? Put your answer in the chat. I know that I should use a coin. And what should I do with my coin? Since we're looking at which gel packs are going to be given to the first 12 runners, the best way to do this is to flip a coin 12 times and record my results. And each one of these, heads would be assigned one of the gel packs and tails would be assigned the other gel pack. We would keep a tab of what we landed on each time, and we would use that as our experimental probability. Now let's look at the other ones. Number 1 says there is a 60% chance of rain for each of the next 2 days. We want to describe a method that we could use to find the experimental probability of having rain on both of the next 2 days. Well, since it's 60%, I could put marbles in a bag where 60% of the marbles represented rain. So in this case, I said put 5 marbles in a bag, 3 blue and 2 red. Blue represents rain and red represents no rain. So this is 60% because there are 3 blue out of 5 total. And 3 over 5 is the same as 0.6. Well, as a percent, this is 60%. So 3/5 is 60%. Now, if you don't see that right away, you could do something as simple as 10 marbles and 6 of them represent rain. You want to pull 2 marbles out of the bag at random because we want to find the probability of it raining on both of the next 2 days. So you would do it for one day and then the second day. Now you would want to repeat that simulation multiple times so that you have an experimental probability that shows this. Number 2, during the regular season, Keisha had base hits 40% of her times at bat. We want to describe an experiment she could use to simulate her next 20 times at bat. Well, we would want something that would show 40% of the time that Keisha had base hits. So for this, I could put 10 marbles in a bag, and if 4 are red, then 6 are blue, then the red are going to represent a base hit because 4 red out of 10 is 40%. Well, I would pull a marble out of the bag and then replace it and do the same thing 20 times because we know that she is going to be at bat 20 times. Number 3 says there is a 35% chance that Meredith will score the next time she shoots a free throw. Describe an experiment using random numbers that she could use to simulate her next time shooting a free throw. Well, since this specifically said using random numbers, I would want to label numbers, and because it's a percent, the easiest way for me to do this is to label numbers 1 through 100. And I could just put them in a bag. 1 through 35 is 35%. So any number that you would choose that was 1 through 35 would represent Meredith's scoring. And any number 36 through 100 will represent her not scoring. Then you would just draw numbers out of the bag and record the results. Number 4 says there is a 65% chance that Colby will forget to take his lunchbox home from work. We want to describe an experiment using 20 numbers that could be used to simulate the probability that Colby will forget to take his lunchbox home. Well, if we're using 20 numbers, then that means we're using the numbers 1 through 20. And 65% of those numbers need to represent him forgetting to take his lunchbox home. So 1 through 13 are going to represent him forgetting to bring the lunchbox home. Because if I do 13 out of 20, that is 0.65 or 65%. The rest of the numbers, 14 through 20, are going to represent him remembering to bring his lunchbox home. And we would just draw numbers out of the bag randomly and record the results.